Today we're going to go back to verifying identities using our sum and difference formulas. It's just now we're going to introduce specific angle values for the formulas, and then we're also going to introduce graphs into our equations. So for our first example, I have sine of x plus pi over 2, and I want to prove that this is equal to cosine of x. So the first thing you notice is that there is no more alpha and beta, but we think as x, or we would view x as like the alpha in the formula, and we would view pi over 2 as the beta in the formula. So it's a simple transition using the formulas. So based on the formula, so we would be looking at the sine of alpha plus beta, and I would use that formula. So I would split it up, and I have sine of x times cosine of pi over 2 plus cosine x times sine of pi over 2. And now because we have an actual angle, I'm going to be able to evaluate two of these. So to kind of reference back to our unit circle, I know pi over 2 is going straight up, so the coordinate for that is 0, 1. So we're going to use that. So sine of x stays sine of x. But cosine of a pi over 2, I use the x part of the coordinate, and I know my r is 1, so it'd be 0 over 1. And then I have cosine of x, and sine is the y part of the coordinate, so I'd have 1 over 1. And we know 0 over anything is just 0, so 0 times sine would cancel out and that would go away. Cosine times 1 would be cosine, so I'm left with cosine of x, and I verified the identity. So notice we're kind of building off of all the skills that we've learned thus far. We have the unit circle to find our coordinate, to find exact values, but still using the idea of verifying. So now we're going to do another one, but now where we have a picture and we're trying to verify. And so our example is y equals sine times x minus 3 pi over 2. And what we don't know is what it's equal to, but instead I give you a picture. So the picture that's given to you would look like this. This right here is 2 pi, and the picture itself looks like so. So based on this picture, we need to figure out what we need to set it equal to. So I can see that my amplitude is 1. My b value has to be 1 because the period is 2 pi. And I'm starting at 0, so there's no c value. So this equation would be y equals cosine of x. So we're taking these two things, so I'm going to set this equal to that, and I'm trying to prove that they are equal. So I have sine of x minus 3 pi over 2, and I'm trying to prove it's equal to cosine of x. So again, we're going to use our identities. X is alpha, 3 pi over 2 is beta, and I use the formula. So I get sine of x cosine of a 3 pi over 2 minus cosine x times sine of 3 pi over 2. And now we have to kind of think about the unit circle. So I know 3 pi over 2 is straight down, so it's the opposite of the last coordinate that we used. So this coordinate is a 0, negative 1. So going back here, I can't replace sine of x with anything because it's just simply sine of x. Cosine of 3 pi over 2 would be the x part of the coordinate, so 0, minus cosine of x, and the sine part of the coordinate is a negative 1. 0 times sine would be 0, so that would be gone. Cosine times a negative 1 would be a positive cosine. And now we've proved that cosine of x is equal to cosine of x. So it's very similar to the last one that we did. It's just now you have to figure out what you're trying to prove it's going to be equal to. So that's all for today. We'll pick up with this tomorrow.